Here is the next idea. We have two curves. Draw a picture. Let's go to just two nice parabolas. You have let's say this is y equals negative x squared plus 9. And I draw another one. What would be a nice, let's just do x squared plus 7. The reason I chose these two curves is because it is not too hard with mental math to figure out that these two curves intersect at negative 1 comma 8 and 1 comma 8. If I wanted to, for the green curve, I could go down to here, and take out my green crayon. Based on what we learned in the last section, I could find that area. It would just be the definite integral from negative 1 to 1. I could also, with my blue curve, do the same thing. Take out a blue crayon. And do this. Now, if I took my blue crayon and I subtracted the green crayon, you have no idea how enjoyable that is. What I would get is the area between the two curves. So what I did was I took the integral of the blue one from negative 1 to 1. I'm going to call the blue graph, if we have different labels for this. This can be f of x. The green one can be g of x. What I did is I said if I find the integral of f of x dx, and then I subtract the integral from negative 1 to 1 of g of x dx, what I would be left with is the area between the two curves. And from our properties of integrals and our properties of definite integrals, this would be the same as the integral from negative 1 to 1 of f of x minus g of x. This was one of our rules. That if I want to subtract the two areas, I could have just subtracted the functions first on the inside. Subtracting the blue one minus this one would give me negative 2x squared, 9 minus 7 plus 2. Gives me a new parabola, and the area of that underneath the curve of that new parabola will be identical to the area in between these two curves, which is kind of nice because integrating what I have here at the black is a lot less work than integrating the two separately, plugging in things into two different things separately and figuring all of that mental math out. So this is the idea of the area between two curves. You could take each area separately, but you could also combine them together. So one of the things that is helpful when figuring out the area between two curves is knowing which is the curve that is above and which is the curve that is below. With parabolas, that's pretty easy. Can you see that this would be the red one because it's opening down, and this would be the blue one because it's opening up? If I want to find the area between those two curves, I need to first figure out from what point to what point am I going? In other words, where do they intersect? Well, how do you find out where two curves intersect? You just have to make the equations equal to each other, solve for x, and we get plus or minus 2. So we now know that we would have to figure out the area going from minus 2 to plus 2. Second, we just need to find that area using the formula that you'll take one, subtract the other. Now, technically, you should know which function is on top and which function is on the bottom. If you screw up and do them in the wrong order, it really doesn't matter. You will just get the same answer but negative instead of positive. So if you got the wrong answer, don't erase out all your work because your answer is negative. Just go and add absolute value bars around everything as you went, and it meant the same thing. It's like perfectly fine. But sometimes it's easy, like on this one, if these two intersect, it's pretty easy to tell that the one parabola that's going down has to be the one that is on the top. So we take this equation minus the other equation, and instead of finding each integral separately, we do a bunch of simplification because it'll make our life easier. Of course, if this is a calculator question, you'd figure it out right away. Type it into your calculator and solve. If it's non-calculator, you would have to do the integral, add 1 to the exponents, and divide. You don't have to write down all those numbers if you don't want to. The answer is 64 over 3. If you do like to show the calculations, you can write them down. I want you to try the next one on your own. And when you see the picture, the first thing that students sometimes comes to their mind is like, ooh, but some of it's negative. Does that cause a problem? No. For the area between two curves, the way that all the mathematics works out when you're adding, subtracting, it doesn't matter that part of the curve is below and part of the curve is above. You don't have to worry about that at all. So for the area between these two curves, you just have to do g of x minus f of x from the points that they intersect. Doesn't matter that part of it's above and part of it below the x-axis. I'll put up the answer for this one to see how you did. So first of all, find out where they intersected at -1 and 4. The line is on top, so we do the line minus the parabola. And then you would integrate. I didn't show the work for plugging things in, but you should have got 125/6.